All right, so this unit we're starting is on integration, and integration is basically just the opposite of taking the derivative. Let me ask you guys a couple questions. Let's say I tell you that the derivative of a function is 3x squared. What must that original function have been? All right, so the original function must have been x cubed because the derivative of x cubed is 3x squared. Let's look at a couple others. Let's say that the derivative of a function is, I don't know, 5x to the fourth. What must that original function have been? Okay, x to the fifth, because the derivative of x to the fifth is 5x to the fourth. So if you're seeing the pattern here, what's happening is we're adding 1 to this, and then we're dividing by that new exponent. So let's try another one that's a little bit harder. So let's say we have f prime of x equals 6x to the fourth. What must the original function have been? Okay, well, the original function must have been 6 over 5 x to the fifth. If you take the derivative of this, you get 6x to the fourth. And the pattern you should be seeing is that you're adding 1 to this exponent, and then you're dividing by that new exponent. So if I were to ask you in general, if we have the derivative is x to the n, what was the original function? Well, the original function must have been x to the n plus 1 divided by n plus 1. If you take the derivative of this, you would get x to the n. All right, so let's look at this a little more carefully. So what we're doing here is called anti-differentiation. And anti-differentiation is simply the inverse of differentiation, so you're going backwards. The antiderivative, you usually use a capital F to describe it. So if the derivative of a function is f of x, then that means that it was the antiderivative of f. So for example, we just did this one, but we'll look at it again. Capital F of x here, the antiderivative of 3x squared would be x cubed. And the reason that's true is because the derivative of this capital F function is 3x squared. And so that means that this capital F function is the antiderivative of f of x. Now, there's one slight other little thing here. I could have said that my antiderivative was x cubed plus 2. And why does that work? So that works because the derivative of 2 is 0. I could have also said plus 5 or plus 51 or minus 100 or any other constant that I want to put at the end because the derivative of a constant is 0. So the way that we write that to represent that infinite amount of things that we could add at the end is we say plus c. So the real antiderivative here is x cubed plus c. And notice I say antidifferentiation or indefinite integration is the operation of finding all solutions. So that means you have to have that plus c, where c is the constant of integration. Okay, so when we talk about antidifferentiation, this is simply the inverse of differentiation. And an antiderivative is a function, capital F, a function f is an antiderivative of f on an interval I if for all x on I, the derivative of capital F equals f. So for example here, if I say find the antiderivative if f of x equals 3x squared, well, that's simply f of x equals x cubed. And that's true because if I take the derivative of f of x, I get 3x squared. So that means the antiderivative of 3x squared is x cubed. Now, one other thing to add in here is, let's say I do plus 2 at the end. Is the derivative still 3x squared? Well, it is. So my antiderivative could have a plus 2 at the end. It could have a minus 100 at the end. It could have a plus pi at the end. It could have any constant that I want because the derivative of a constant is 0. So what we do to represent that is we say plus c, and c is that constant of integration. So my real antiderivative of 3x squared is x cubed plus c. So let's look at some notation here. So my integral sign here is this little curvy guy. My variable, my integrand is this f of x. The variable of integration is dx. That means that I'm taking the integral with respect to d. The antiderivative is this capital F of x. And then we have our constant of integration, which is plus c here. So basic rules of integration. So if I have a constant and I take the derivative, I get 0. So if I take the antiderivative of 0, I get a constant. The derivative of kx would just be k, so the antiderivative or the integral of k would be kx plus any constant c. Same thing happens here. The derivative of k times f of x is k f prime of x. So the antiderivative of kf of x is k, and then the antiderivative of f of x plus c. Same thing happens here. So if I take the derivative of two functions that are being added or subtracted, I just take the derivative separately. Same thing happens with my integration. So it's the antiderivative of f plus or minus the antiderivative of g, and then plus my constant c. Derivative of sine we know is cosine. And so that means the integral of cosine is sine plus the constant of integration. Derivative of cosine is negative sine. So that means the integral of sine is negative cosine plus our constant of integration. Now we've got a couple examples here. So the integral of 7 dx is 7x plus c. The integral of x to the 5th would be x to the 6th over 6 plus c. The integral here would be x to the 5th over 5 minus x cubed over 3 plus c. So remember, we're adding 1 to the exponent and then dividing by that new exponent. This would be just 3x cubed over 3, and the 3's cancel, so it's really x cubed, and then minus 7x squared over 2 minus 8x plus c. This one would be pi x squared over 2 plus 1 over pi x plus your constant of integration, don't forget that. Here I'm going to rewrite this as the integral of x to the 1/2 dx, just so it's a little bit easier to think about. If I add 1 to that, I get x to the 3/2, and if I divide by 3/2, that's the same thing as multiplying by 2/3, plus my constant of integration. Here, if I double distribute, this is the same thing as integral of 4x squared minus 12x plus 9 dx, and that becomes x cubed, 4 over 3x cubed, minus 12 over 6x squared, so minus 6x squared, plus 9x plus c. Here, I'm going to rethink about this as the integral of x squared over x to the fourth, which is x to the negative second, plus, and then I divide again, 3x to the negative third, and then 1 over x to the fourth is x to the negative fourth dx. And now I add and divide by my new exponents, so I get negative 2 plus 1 is negative 1, plus negative 3 plus 1 is negative 2, negative 4 plus 1 is negative 3, and then plus c. All right, last two. The integral of sine, if you remember from up here, is cosine. Or I'm sorry, the integral of sine is negative cosine. So the integral of 4 sine x is negative 4 cosine x plus c. I'm going to rewrite this integral as integral of negative sine x, and tangent is sine over cosine. So that's the same thing as times cosine x over sine x dx. The signs are going to cancel. So I'm really taking the integral of negative cosine. And if you remember, the integral of cosine is sine. So this becomes negative sine x plus c. Function. Can I find a particular solution? So for example here, I say the derivative is 3x minus 1. So that means the antiderivative, f of x, is 3x squared over 2 minus x plus c. And actually we're calling the this function f. So I'm just going to go ahead and call this lowercase f here. Now they tell us that when x is 2, y is 3 in this function f. So I'm going to make y equal 3 and plug 2 in for x and see if I can solve for that c value, which I think I can. This is a 2. All right, so mental math, 2 squared is 4. 4 times 3 is 12. 12 divided by 2 is 6. 6 minus 2 is 4. And so I get 3 equals 4 plus c. Subtract the 4 over, and c is negative 1. So that means my particular solution here says that f of x equals 3 over 2x squared minus x minus 1. And that's my particular solution here, meaning that that's the antiderivative that has that point on it. Find the particular solution for f. So here we're given the second derivative. If I take the antiderivative of the second derivative, I get the first. And then if I take the antiderivative of the first, I get the original function. So I'm going to say the antiderivative of 2 is 2x plus c. So that must be my first derivative. And they tell me that when y is 1, x is 4. And so I can solve. 2 times 4 is 8, and 1 minus 8 is negative 7. So that's my c value. So that means the first derivative is 2x minus 7. And now if I integrate that again, I get the original function. So f of x equals x squared minus 7x plus c. And if I substitute this point in, negative 1 for x and 2 for y, 2 equals negative 1 squared minus 7 times negative 1 plus c. And I solve, I should get my c value. So negative 1 squared is 1 minus 7 times negative 1. That's 8. 2 minus 8 is negative 6. So I get negative 6 equals c, which tells me that f of x equals x squared minus 7x minus 6. That is it. and